Well, good afternoon, everyone. Welcome to Hydrocarbon Refrigerants, the R600 class. I hope that everybody is having a great day. I'm hoping that everybody is out there enjoying the this beautiful uh, spring weather. It's really nice here. So today we're going to talk about, to begin with, hydrocarbon refrigerants. We're going to go ahead and jump right in and get started. So one of the things that I'm gonna go over. This is actually the class that is presented at the Lokring class. So this is your what you would normally be doing. You'd be giving. You'd be excuse me. You would be. We would be giving introductions. We'd talk about a hydrocarbon refrigerant safety lecture. We'd be going through the breakdown. We'll take a break. Then we're going to do an evacuation and recharge demonstration, the lock ring knowledge base, hands-on lab, the knowledge check, and then a wrap up. So this class would get you certified if we were teaching this with everybody in the class itself. This is how you would get certified. Okay, this one is our virtual class, and don't offer certification with this class. Okay, so the histories we're going to talk about like it originally said, we're talking about refrigerants. Okay, so in the 1900s, HCs were used. Okay, hydrocarbons, and the infant refrigeration industry. And then in the 1930s, CFCs were developed and they were non-flammable. And the they reduced all the HCs, phased them out, and everything was used with CFCs. Okay. In the 70s, they decided, oops, we're depleting the ozone. So the CFCs, we had to phase the CFCs out. Okay, so in the 1980s, HFC and HC started to replace all of the CFCs. Okay, so in that 10-year period, they realized that there was an ozone depletion, and they had to phase those out. Which, if you think about it, R12 was what was used in the 1930s up until about the 80s. They were phasing them out. Whenever they discovered the ozone depletion, they decided that they needed to get rid of the hydrocarbons. In 10 years, whenever they discovered those depletions, they started developing HFCs, and then they went back to the HC. They changed they changed the blends of the HCs, and they started replacing the CFCs with HFC. Okay. So in 2000, they launched an HC ice cream cabinet. Okay. That is not here. That is in Europe. Okay. In 2005, they had over 50,000 HC cabinets that they used in Europe. In 2020, they had over 5 million HC appliances that were being used worldwide. So we had phased out the CFCs, replaced it with an HFC, as we are in 134A, which is what the HFC was, and then they started phasing out the HFCs and started replacing it again with the HCs, which is your basically your butane mixture. Okay, so here's kind of a list of it. R12, that's the first one. Whenever I was in my infancy stage as an employee working on refrigeration, that was R12. Okay. That was the CFC. The ozone depletion rate was 1. Okay. Your 134A came about. R12 was phased out. We went to R134A. That was an HFC. At the same time, we had moved around and moved some other stuff, in place of the R134A. They had come out with a in the R12, in between the R12 and the R134A, they had what they called a hot shot. That was a drop in for the R12. Okay, that didn't work very well. They went ahead and moved to the 134A. At that point, we removed from the 134A to the R600A in the refrigeration portion of appliances. Then you had R290. There is also an R441. The R441 kind of replaces what they used in the ice machines. Okay. Then we had R404A. That's an HFC. They changed the R404A HFC to a R170, which is a hydrocarbon. And then, of course, the R32 is the HFC also. If you're looking right here, here's your ozone depletion rate. R12 is the only thing in there that has a depletion rate. Okay, so if you look right here, this is the GWP baseline, and then of course if you look at on the very bottom, you can see that in 2016 is when they started really driving this down. In 2018, they were at 90%. They were trying to drop it, as they have, like today is 2000. This slide was made in 2024. So they're looking at dropping it down to a 60 on the GWP. Okay, so that needs to pull out in about 2000, just about 2000 and 2030, 2029, I think is where it is. They're gonna drop it again, and then of course they cycle it down to 20. Then they cycle it down to 15. That's in 2036. If you have noticed, your refrigerant, if you release refrigerant into the atmosphere, it has changed from a $5,000 fine to a $50,000 fine, which is what they are at today. So if you make the mistake of releasing refrigerant into the atmosphere and you get caught, they can fine you up to $50,000 today. Okay, so we got R600, which is our A3 classification, and it does not require recovery. Same thing with R290. You don't have to recover 290, but they are flammable. So this flammable refrigerant, you have to be very careful whenever you're using it. One of the things that people don't realize is that the oil that is in the compressor actually will absorb some of the refrigerant, and you can have a flash fire that's caused by that. Okay, so exactly what is required for me to get flame? Okay, I need to have fuel. That would be my refrigerant today. Then I need air. Okay, once I have the air that's that's all around us, then we have to have an ignition source. So what people don't realize today everybody thinks, oh, well, my ignition source is my torch, which is true. If I have those three in combination, that I get a flame. So what happens is, if I heat my torch, if I fire my torch up, all I have to do is have refrigerant in the air. I don't know how you guys heat your torch. Some you use the clicker, is what I call it. So it has a little round piece that has a spark, a flint that goes across it, and then that will ignite your torch. Most guys normally that I see use some other type of flame, such as a lighter or something like that. Well, all I got to do is strike that lighter or have that source right there, and I've got the air, I've got the fuel, and I have that flame, and it ignites. And the problem is, it ignites with a good force. One of the things that I keep asking people to do is whenever you have a chance and you just want to go out and you want to scroll through a couple of videos, go out go out and look at videos. Just type in R600 explosion, and it will actually show you those out there. Okay, so we have a sudden release of refrigerant with a proper combination with the air and the fuel. I can have a flash fire. If I have a flash fire, I'm usually going to have a sustained fire that's going to follow up with that. If that continues, I'm going to end up with an explosion sooner or later. Okay. So we don't want to use anything that could cause a reaction to get this ignition, this flame, to come out. So we don't want to use a torch. So what are the options? One of the options is the Lokring Lokring system. Now, is the Lokring Lokring system the cheapest system out there? No, it's not. Is it definitely more expensive than some of the others? It is a little bit more expensive, but there's a reason. These are tested. As long as you do use this unit, if I use the Lokring system, I have no problems having to go back. If I allow it to cure, the curing time, I'm ready to go. So we're going to move on. So our LEL and my LFL. Okay. So low flame liability limit. That's LFL, low flame limit. Okay. So that's our R290 and R600A. There, R600A is at 1.8%. Okay, the EUL and the UFL, not the that's the upper flammability limit. Okay, our R600 is at 8.5, so that's pretty high. So the last thing we want to do is to get it so that we're having a flammability issue. Okay, so who kind of regulates everything with us? With us, the ones you want to be concerned with are the Environmental Protection Agency, which is the EPA, which is where you get the certification from. I'm going to need the National Fire Protection Agency. That's the NFPA. I'm going to need the UL, which is Underwriters Laboratory. Then we have the International Electromechanical Commission. That's the IEC. And then we have the American Society of Heating, Refrigeration, and Air Conditioning Engineers, which is the ASHRAE. Okay, so that's the ones that we want to be concerned with. Okay, whenever I come in and I look at the tag, okay, I should have this danger, risk of fire or explosion, flammability, refrigerant used. Do not use mechanical devices to defrost the refrigerator, and do not puncture the refrigerant tubing. If you do, you run the risk of actually causing the fire. Okay, so we're going to charge our what's on that label is our charge size, the refrigerant type, by the EPA and the SNAP regulations. So you can tell right there with the arrow that we are using R600A. Means that we can't have any retrofitting done. All labels must match and must meet UL specifications. Okay. Who kind of oversees all of this? AHAM, the Association of Home Appliance Manufacturers. RSES. Okay, a lot of the others we don't really use. Okay, so one of the things that I tell everybody whenever I'm doing refrigerant and it's R600A, I have two things that I keep right by my side. Okay, one is the fire extinguisher. Okay. What kind of fires extinguisher? I'll spit it out in a minute. What kind of fire extinguisher do I use? I have a dry powder. Okay, so if I carry the R600 on my truck, I have to have that. Okay, of course, if I have that, then I have to have the MSDS sheet to go along with it. That has to be in my truck, in my MSDS sheet. Okay. You're supposed to have an MSDS sheet for anything that you carry in your truck. An example would be some of the cleaners. Anything that refrigerant, that has to have your MSDS sheet. Again, you have to have a tubing cutter. You can't use a torch. You have to have a very well ventilated area. One of the other things, I have a little my fire extinguisher is not very big. Oh, it's about this tall. Okay. Then along with my fire extinguisher, I have a little fan that I carry because my drill has a battery I can disconnect, and then I can use that to keep the air moving in my area. Okay, I'm going to have a combustible leak detector. Okay, the way I can pre-check, make sure that I don't have any leaks before and after I do my work. Okay, and then I'm going to make sure that I have to eliminate any kind of ignition source. And ignition sources are what I'm going to talk about right now. Okay. Your obvious ignition source, of course, is anything that has a flame. It could be a match. It could be my torch. It could be a cigarette, a candle. It could be a toaster or a range, a dryer, a torch, spark igniter. Okay. The things that you have to think keeping in the back of your mind is that if I don't have a brushless vacuum pump, or my recovery equipment has got to be brushless, that's my ignition source. Okay. Other things that you need to think about: timers, switches, contactors. The main thing that we overlook in the summer, whenever we get into the winter, is static electricity. Okay. So you need to make sure that you're in the back of your mind, you're always thinking about, do I have an ignition source? So if I'm in a customer's home and I am trying to work on an R600 refrigerator and they have a gas stove, that's an ignition source. If they have an electric stove, they turn that on. That's an ignition source. The actual light switch that you turn on, that's an ignition source. Okay. So you've got to make sure that we have to eliminate everything that we can. Okay. So our AHAM recommended practice, tubing cutter to remove the components. They want you to use soap bubbles or a certified leak detector. I prefer both. I always carry it. You can always buy little small bottles of leak detector. As long as I keep the lid on it tight, I'm good. And if I'm going to try to check anything, I can only use dry nitrogen. Okay, I can't use anything else to check it with. Okay, I'm going to constantly monitor everything for my flammability environment. Okay, so that's the reason that I keep these two things with me at all times whenever I'm working on anything that has R600. I'm going to keep my extinguisher, and then I'm going to keep my leak detector with me, and that's what I'm going to use in case I have a flash fire. I can use my dry powder fire extinguisher, and I can monitor my any leakage with my leak detector. Okay, so we're gonna go back. So we're gonna constantly monitor that. Like I said, we're gonna purge any gas into the external environment. That doesn't mean that I do it in the house, because if I do, you're gonna blow something up. Okay. Do not use the external heating source to defrost. In other words, you can't use a heat gun, and you can't use a hair dryer. Okay, you can't use anything like that. Do not use compressed air or oxygen if you're trying to flesh something out, especially oxygen. If I'm using oxygen, of course, that's one of the legs of my combustibility. Okay, once I get through and I am done, and I have checked everything, and I'm satisfied with my work, I'm going to put a red paint on the access fitting. That lets the next technician that comes out know that I have been in the system and I have repaired something. It also tells that I have let them know that they need to probably ask the customer what was done last time. Okay. The other thing is, just like anything else, you're supposed to remove any kind of piercing valve. Okay. So lock prep versus UV leak detection. Okay. My lock prep fluoresces with a bluish green under a UV light. Common refrigerant dyes as a bright yellow. Anybody that's used refrigerant dyes knows that most of them are bright yellow. And environmental condition is, of course, the lights off. You also have to have your UV light and my UV glasses. Okay. AHEM recommended practices for recharging or replacing refrigerant. If you look right here is my refrigerant on the very bottom right there in front of the case. Okay, I've got my brushless vacuum pump right there, and then of course I have this all in line. Whenever I order it from Lokring, I get everything, plus I also get a a sheet that spreads out, about it's about 28 to 32 inches, and you open it up, and it shows you exactly how you should have this whole system ready. Okay, so I'm going to repair any electrical faults. I'm going to secure any power. I'm going to discharge all the capacitors. Once again, there's my spark. Okay, my system remains grounded. Then I'm going to, any of the lines I have to be that are going to be exposed, I have to insulate those lines that are exposed to corrosive material. I have to insulate those. Okay, then I can renew my seals and sealing material. Okay, so if you look right here, here's the pinch line, the pinch clamp for the for the tool, and then I can screw my line back on there. I do not recommend using this, because if I do, I can get some of the incandescent bulbs particles into my thing. So I'm going to maintain my ventilation. I'm going to make sure that I'm properly grounded. I'm going to verify the venting is allowed. Okay. Verify the venting for R32 and R452. Then temporary vessel for release. Then my compatible hoses at the sufficient lengths. Okay. So what I recommend is that Vulcan has a bag that that they sell, and you can get it from Encompass, and I can drain my R600 into the bag, and then I don't have anything out there. Also, whenever you come in with the bag, I don't have to worry about the kit that I buy from Vulcan. Has it's about a 35-foot hose, and you could vent it outside. They have had somebody that was outside smoking and actually caught themselves on fire because they were smoking a cigarette and somebody was venting R600 at the same time. Okay. So I recommend that you do this for safety, and I use a bag. After I get done, it is required for me to have this decal on the backs right at where the compressor is. Tells right here that it's an R600, and I have a flammability issue if I'm using it. Okay, I have a guy that I was working with who sent me a picture. I should have included into the here. One of the guys he was a new technician. He's the normal technician told him, "Hey, listen, I got to go run to the office. Stay right here. Don't do anything. I'll be right back." Well, the guy said, "Well, I just wanted to make sure that we got done as quickly as we could." So I went ahead and I used a torch to unsolder the compressor, and it burned down almost the whole shop that they had. Okay, so my safety labels, I've got to have those whenever I replace them. If they're not on there, I have to carry some in my truck so that I can put those two labels on there. Okay, I'm going to use my red markings on my process tube. I'm going to install ventilation features. Mine is a fan. Compressor oils may still contain residual refrigerant. Up to 35% of the oil can contain refrigerant. Okay. 0 PSI does not mean zero refrigerant. That's one of the things you need to make sure that you remember. Okay. Here is this charging kit that from Vulcan. If you see right there, there's about a 30-foot hose. Maybe it's a little longer. It comes with the kit. There's the piece that I told you folded out. This is a picture of it, and of course you get everything that you're going to need in the kit, both the low side, the high side, the gauges, everything else. So this is a complete set. Okay, it has a low pressure, high pressure manifold, R600 extraction valve, my liquid extraction disc, which is right there on the left hand side at the big piece that's white. We have a set of ball valves and T's that come with this kit. It has valve core depressors in this kit, and it also comes with the hoses, both the hoses, the hoses right there that you see at the very top that I was talking about, and your regular hose that you use for your high pressure and your low pressure sides. Okay, so I'm going to perform, once I get everything done, I'm going to make sure that I have a safety check that I've done. Okay, I'm going to monitor it with my leak detector, which is what I've already said. I just lay mine on the floor and it ticks just like I've had one for years. Whenever I worked on gas, which is very popular in Atlanta, Georgia, which is where I'm from, I always had one of these leak detectors for a gas leak detector. So I'm used to the ticking sound that the gas leak detector makes. So you're going to run refrigerant for 5 minutes to warm the oil. So I'm going to plug the unit on. I'm going to let it run for 5 minutes. The problem I'm going to have is if my compressor is totally bad, okay, and it's not working and I can't get it to work, then I have got to just go ahead and cut the lines, and I have to be very careful whenever I'm picking this up out of whatever it is, the back of the refrigerator. Could be that you're using a ice maker, under the counter ice maker. I've got to be very careful. I can't spill any, because that's like I said, that oil still has a lot of flammability to it. Okay, I'm going to install a suction gauge, install the discharge hose to the piercing with the piercing pliers. Then I'm going to route the weighted end to the outside piercing dryer. Okay, so one of the nice things that if I buy my product from Vulcan is this. This is my this right here is, of course, my dryer, and it has a valve already on it. You don't ever have to take it off. But what I do is I take this, I put some leak lock around the thread right there. I put this all the way back on. Of course, I take my 3/8 wrench, attach it here, take a pair of pliers, and I tighten it up as tight as I can get it with my hand, and then I may try to turn it a quarter of a turn. Okay. Then I have a pinch off capillary tube. That's in case I need to, for the capillary tube. You need to, I was taught whenever I was ever since I started, I use a mill bastard file, and that's the capillary tube that's the way that I take my capillary tube out. Okay. So what I'm going to do is I'm going to confirm the gas is being discharged. I'm going to start the unit, going to monitor the suction pressure. Okay. I'm going to achieve the minimum of the stable atmosphere. Then I'm going to unplug the unit, remove both pliers, and perform my service. Once I perform my service, I'm going to check I'm going to do a safety check, and I'm going to monitor it. This is for a non-working. The compressor to the system is the same. Confirm the gas is being discharged. Passive recovery only, no external heat sources, which is what we said from the very beginning. We're going to close all the open ports prior to transporting. So once again, I've got to somehow, me personally, I drain all of the oil in a container, and then I seal that container. Okay. My connection to both sides of the system is required. Passive discharge, assisted discharge, and my passive discharge. Then I'm going to repeat it to try to get rid of all of the trapped refrigerant. Okay. This right here, I'm going to tell you, if I was doing refrigeration work now, I would have a set of these pliers. I understand that they're $174. I still would have these. If I'm using any kind of refrigerant tubing and I'm cutting it, I really, really like these tools. This tool right here is so great. I only have to have a quarter of a turn, and I can cut everything off. Okay. I need 120 degrees is what I have to have. Okay. This right here is the charging connection. That is what we were talking about. This is the chart that you get with your device. Okay. Of course, I'm going to go here to the testing. Okay. Then we're going to open it up. We're going to evacuate the system, open the valve core depressors, connect to the evacuation until a minimum of 29.9 vacuum is reached. I'm going to isolate the vacuum pump. Then I'm going to monitor for a pressure rise. If none, then I'm ready to charge the system. Okay. So if this unit has 40 grams or more, I can charge from the liquid side. Up to 40 grams, I can only charge on I can't charge on the liquid side. Okay, it's only the high side. So I can not charge the low side. If I do that, I will make this little valve will explode. Not explode, but it won't work. And they do check every single one that they come in. And if you have one and you have charged it and you got it above of 70, you're going to end up with a broken valve. If you nail it all the way on the other side, that valve is no good. Okay, I'm going to close the manifold gauge. I'm going to close the ball valve extractor. Then the ball valve to the vacuum pump remains closed. Okay, place my bottle on the scale. I'm going to tare that to 0 after I place it on the scale. Open my extraction valve on the bottle. Do not move the bottle from the tear on the scale at this point. If I do, I've messed everything up. Okay, I'm going to open my ball valve, fill with half of the charge, energize the compressor at this point. I'm going to cycle the ball valve until the charge is reached. Then I'm going to close the extraction valve, open the ball valve once 0 PSI is reached, and then close the low side manifold gauge. Okay, so once again, they tell you do not charge if it's not recommended to do it for charges under 40 grams. But I can, once it's over 40 grams, I invert the bottle just like you do to charge on the liquid side. I'm going to close the manifold gauge. I'm going to close the ball valve to the extractor. Then the ball valve to the vacuum pump remains closed. I'm going to get a liquid line extraction disc. I'm going to place the bottle on the scale. Again, I'm going to tare it to 0. Then I'm going to go ahead and open my extraction valve, pre-charge the ball valve. then open my ball valve, fill about half the charge. Then I'm going to close the valve. Then I'm just going to cycle the valve on and off rapidly until it becomes fully charged. Then I'm going to close the extraction valve and open the ball valve. Okay, wait 1 minute, start the compressor. Once 0 PSI is reached, I'm going to close the low side manifold valve. Okay, then I'm to remove my charging device. I'm going to verify the compressor's running, crack open the valve core depressor at the dryer, open the high side manifold valve. Sorry, that's a misprint right there. Then I'm gonna slowly open the low pressure manifold valve until both gauges read the same pressures. Then I'm going to close and remove the valve core depressors. Okay, I'm going to close the valve core depressor and remove that. I'm going to apply lock prep to any of the threads. Okay, install the caps. If a more permanent seal is desired, I can crimp it right there near the Schrader valve. Okay, I'm going to apply my red paint to the service point. That way, if another technician comes in, they will know that somebody has worked on it. If you have any questions, one of the great places about Vulcan is they have their own website, www.vulcan.com, Vulkan. That will take me right. That will give me, I can have access to the videos that they have. If I have any other questions, there's a space in there where I can leave a question and they can get back to me. This is a great little tool. Okay, so now we're going to go ahead and we're going to talk about, if I find it here, repair of refrigeration appliances. Normally, this is a 3.5 day class. Okay, whenever the first class is what we just went over. The next class is this class right here. Okay, we're probably not going to have time to go back and go through it since we don't have anybody in the meeting here today. We don't have any comments, so we'll just keep moving along. This will be available in about a day on the website, and you can review it in case you wanted them. So, repair refrigeration appliances. Okay. Advantages to the Lokring system. Okay. Suitable for flammable refrigerants. Customer-friendly on-site service with a reduced logistics cost because I don't have to take it out of the house, bring it back in. I have a lower logistics cost. Okay, it's clean, it's fast, it's reliable. Assembly possible in a high combustion area. Okay. So what does that mean? If I'm working in a restaurant, I can actually do it while people are around. Okay, even with a heavy foot traffic or during the business hour. Simply assemble without the power connection. Okay, the only power connection that is ever needed is to be able to plug my vacuum pump in. Again, brushless vacuum pump. If I use my regular vacuum pump, I can start a fire. Okay. No heavy brazing equipment is necessary. No brazing related quality problems. Okay. We're going to go back. So can I use the Lokring system for my 134A? Absolutely. One of the guys said that he had gone in and repaired a leak that he had found in the evaporator on a refrigerator, and he used this system and actually repaired that. Didn't have to have the customer without his refrigerator for a couple of days. So he really likes it. I like it really. Since we're all going to R600, you might as well go ahead and save all of your pennies, because this is what you're going to have to do. You're going to have to use something similar to this. So you might as well buy the best. If I'm going to do it, I'm going to buy the best that I can. I want the most bang for my buck. My Lokring, I don't worry about my Lokring. If I follow these steps with Lokring, I don't ever have any problems. Okay. So you can't really tell right here. This was a good joint that they had pulled in. Okay, but you can tell that the Lokring system right here, if you look through there, you can really see the advantages to this. Plus, I'm in a tight space. I used to hate it with my torch because some of the times you just couldn't get around, and I had an open flame, and I was always worried that I was gonna melt something. The last thing you wanted to do with my Lokring, I don't have to worry about it. I'm not brazing anything. I don't have any open flame. I can get it any little crack or crevice. I can get it in there and use it. Okay. So my areas of application, they're endless. Okay. Household refrigerators, freezers, wine coolers. I can do all of that. Anything with any of the refrigerants. Okay. Endless possibilities. I can also use it for refrigeration equipment. Okay. I can use those cabinets, the bars, the chillers, the lockers, the refrigeration that they have in a restaurant. Okay. My refrigeration equipment for catering, I can use it for. Sales counter refrigerators, flow through coolers, portable cooling systems. I can use it for all of that. The thing is, the principle of Lokring remains the same. But if I'm going to do it, I need to follow the Lokring principle. Okay. So what are my components? Okay. Basically, I have a joint, which are the two pieces, which is the one piece that's on the far left hand side. I have two rings. The rings and the joint change. Okay. If I'm using aluminum, it's not a brass, it's an aluminum. Okay. And then of course the rings are not brass, they're aluminum also. Then after that, I have my lock prep. So if you look at the diagram on the right, you can see the joint, which is right there. You can see it right there. Okay. Then I've got the two, which are my two rings. Those two rings have to be closed. Okay. They have to be buttoned right up against this ridge that is the joint. Okay. Then I'm going to use lock prep, and I'm going to put it in there, spin this around so that I coat it all the way, and I'm in good shape, and I can go ahead and close the joint. So my areas of connection. Okay. A is my insertion area. So as you can tell, I've got this butted up against each other. Then I've got my stabilization and sealing areas, which is B. If you see how that's the wide area down there on the bottom. And then we have our main sealing area, which is C, which is right there, right around where those two sealing areas begin. Okay. So Our repair possibilities with Lokring, like I said, you can repair anything, all right? I can replace the compressor. I can change out a filter dryer. I can replace a charging tube. I can replace leaky brazed connections, okay? So what kind of material can I use? If I have copper, I can go copper to copper. I can go copper to steel. If I go steel to steel, I still am going to use those little brass fittings. Okay. Then I'm going to go, if I go from aluminum to aluminum, that's my aluminum fitting. Okay. So I have an aluminum fitting for aluminum to aluminum. If I have an aluminum to copper, I'm going to also use that aluminum fitting. Same thing if I'm going aluminum to steel, I'm going to use the aluminum fitting. Okay, now is whenever I would normally be asking you if you had any questions. Since we don't have anybody in the class, I'm just going to continue on. So my starter kit, my repair possibilities for a perfect kit for any of the repairs. I get a hand assembly tool. I get an assembly jaws. Get 2 sets. I get a small set and a large set. I get lock prep, sandpaper, dryer, straight connectors, and then straight reducing connectors. Okay, so here's how they kind of lay out, and you can actually see them. If you look at the number 1 fitting, okay, that's going to be the one that goes from the dryer to the steel line, which is the condenser side. Okay, that's the number 1 fitting right there. You can see it. And then I've got my dryer to my capillary tube. Okay, you notice that if my capillary tube is copper, I'm okay, and I just go copper to copper. If my capillary tube is aluminum, I go copper to aluminum. You can see the fitting right there, which is number 2. Okay. Specially designed for Lokring application, that was the filter dryer that I've already shown you. It has a decedent of XH9, which is the same as any other filter dryer. So once the other thing that I need to look at is my capillary tube. Okay, you can tell that I've gone from a copper to an aluminum. If you notice that fitting is all aluminum. Okay, then if I'm going from my evaporator to my suction line, which is number 4, you look right there. That you can use the copper to the aluminum. I'm going to use that aluminum filter. That aluminum fitting. Okay. Then I've got my back plate condenser, which is my liquid line. That's number 5. You look, that's right up there at the top. So if I have to replace the condenser, I can use that and replace it. If I'm going to replace, let's say that I have a bad joint that is in the condensing coil itself, I can actually repair that with the Lokring tool. I don't have to go and order it. I don't know if you work on, if you work on any Viking. Viking had a unit that their refrigerator, they tried to help cool it. They had it go down into the in where the compressor, and you got, whenever your water drained, they would help evaporate the water by using the liquid line, but it always leaked. So I can use this to replace that. I do not have to cut and solder, and I can just use my Lokring kit and it's a whole lot faster. Okay, our side plate condenser, that's the number 6 right there on the right side. I can go between, both side plates, and I'm ready to go. From right here, I've got a charging stopper, which is right here on number 8. Okay, you can either have just the stopper, or I can have the Schrader valve with it. If I'm going to use the Schrader valve, of course, I have got to seal that off. So I have to use lock prep to seal it off. Okay. Then I have number 9, which is my hot gas line. Shows you right there. That's number 9. You can see that. Number 10 is my suction line in the compressor. So I have a fitting that I can use. That I can use this. You can see it right there in number 10. So I can use that for another source to tap. Okay, my technical specifications. Okay, it's UL SA 12004 has been approved. Reference, the maximum operating pressure, of course, is 25 bars, which is 360 psi. Okay, my temperature range is minus 58 degrees up to 302 degrees. My tubing diameter is 1/16 to 3/8. This is for the 00 fittings. Okay, my minimum tubing wall thickness is 0.5 millimeters. So it has to be at least a 0.5 millimeter wall thickness. Okay, laboratory. Their laboratory is set up according to ISO 14903, which is what is everything now. Okay, the unique laboratory performance test. Of course, they use ISO 14903. It actually is in Germany that their test lab. They do all of these tests. So they have a tightness test that they check to make sure that there's no leak. Then they have a fatigue test. They have a freezing test, a vibration test. Then they have a pressure cycle temperature test. Then they have a vacuum test. Once they advance from the vacuum test, they put it back into a pressure test, which is a static pressure. And then after they get done, they do it at the very beginning for the tightness test. Then they do it at the very end to check the loads. Okay. So what kind of samples are they doing? They take 14 test samples. Is what they use before starting the test. The following parameters are defined. They have the maximum temperature, the minimum temperature, the maximum operating pressure. So those are all defined before they start any of the test. Okay. For the tightness test, okay, before the load test, they're going to test they're going to use the load test, the tightness test. They use a helium gas. They put it at about 68 degrees Fahrenheit. They have a pressure difference of 145 psi, and the maximum leakage rate is a 7.5 times 10 to the minus 8 millibar, which is a huge, so small. Okay, for their fatigue test, they cycle between the maximum operating test and the atmospheric pressure. They cycle this 250,000 cycles. I'm sorry. So I'm going to check all 14 of these. I'm going to run it through a cycle test, which is 250,000 cycles between the maximum operating and the atmospheric pressure. Okay. The next one, they took this and they take the test samples. I submerge them in a container underwater. I'm going to pressure the above water surface is reduced 7.5 psi for 10 minutes. Okay. The trapped air disappears from the cavities while restoring to normal ambient air pressure. The cavities fill up with water. So the test samples are then placed in a freezer for at least 30 minutes at a maximum of 5 degrees Fahrenheit. Okay. Then I test the samples, which are placed into water at room temperature, and it thaws for 5 minutes. Once it passes this test, I have to put it into a vibration test. I take 2 million load cycles, and it runs at the frequency of 200 hertz. Okay, the aptitude is dependent upon the size of the connection. Okay, so my pressure temperature cycle test. Okay, the first thing I'm going to do, I'm going to do this 50 cycles. I'm going to alternate the temperature between the minimum temperature and the maximum temperature. When the maximum temperature is reached, the test samples will be inflated to the maximum operating pressure for 2 minutes. That's 50 cycles that happens. Okay. Then on the second step of this, I'm going to use 200 cycles. So I'm going to go maximum temperature is held. Okay. My pressure alternates between the atmospheric pressure and the maximum operating pressure. Okay. After this test is complete, it now moves along and I do the vacuum test. So this takes an hour. The temperature is 68 degrees Fahrenheit, and then my maximum pressure is 0.2 kilobars. Okay, after it passes that test, I'm going to go to my test laboratory. I'm going to do my pressure test, which is a static test. So it goes for 1 minute. All 14 of my test subjects, they're gonna test the pressure. They go 5 times the maximum operating pressure or the theoretical maximum load of the tube. Okay, so the pressure test, the Lokring connector is always stronger than the tube. As you can see, this one is blown out where they inflated it so high. Okay. After they get done with that, they do a tightness test after the load test. Okay. So they've got, of course, it's helium gas. They go at 68 degrees Fahrenheit. The pressure difference is 145 psi that it goes between. And then, of course, the maximum leakage rate is at 7.5 times 10 to the minus 8 millibar. Okay, now we're going to move on to the assembly tools that we use. Okay, this HMRK is your assembly tool. Okay, it's specially developed for the Lokring assembly. Its patented lever action mechanism is used for the minimum effort. Okay. They also have one that is not a. You don't have to use it at all. You mash a button and it seals it for you. You have to be a whole lot more careful with that, but it is very nice and very quick, and it very expensive. Okay. My assembly jaws are easy to change for different tubing diameters. Really, the only time you have to change the jaws on this is whenever I'm working with 3/8 tubing. Okay. Both handles bend, which is very nice for hard to reach areas. And of course, it's German technology. Okay. So the assembly jaws, the MB8 is for 1/16 to a 5/16 inch tubing. Then the MB10 is for my 3/8 tubing. Okay. So lock prep. Without lock prep, the system doesn't work. And you have got to have fresh lock prep. Anything over a year old, you throw the tube away. So for double O refrigerant, double O size, I'm going to use my lock prep as 65 Gs. It's a 65G. Now, if you look at the picture there, right under Vulcan lock prep, that is where you're going to find the date. So do not use it. If it is over a year old, throw it away. This is where problems occur. If you use it that's older than a year, you run the risk of it not sealing properly. Okay? So throw it away if it's over a year old. Don't do it. Okay? My lock prep 65G compensates for any unevenness in the tube surface itself. It hardens under the oxidation exclusion and in contact with free metal ions. Okay, it stays elastic. It ensures that every lock ring connection is hermetically sealed. Okay, my assembly instructions for the lock ring, double O connectors. First thing I'm going to do is I'm going to clean the tubing ends. Number one, never clean your tubing ends in that manner. I run the risk of whenever I'm using my sandpaper to sand, if I get too close to the edge, which I need to be as close as I can, you need to have it solid. I use the double loop method. Some of the other guys, they don't use this double loop method. If you look at right on the left side over there, they use just the single, and you take and turn it with your hand, and you clean off the tubing. Okay, so I use the double loop method. That's the way that I was taught. Like I said, I've done this so long that it's all second nature. So that's the way that I use it. Okay, so once I get all this and got it cleaned up and I'm ready, and I've got the two pieces cut, I'm ready to make my connection. I'm going to apply my lock prep 65G to the tubing end. I'm inserted all the way in. Then I do the same thing on the other side. Quickly insert the other end. I hold that connecting so that I can spin it around. They say 360 degrees, but I do 740. Okay, so I'm going to insert my tubing ends into the lock ring connector until the tubes reach the inner stop. That's what we're trying to do. You see the inner stop, which is right there. So I've got to pull these together, and I've got to hold my fitting so that, excuse me, so that it never slips. So I actually take two fingers. That's how I hold the fitting, and then I hold it in place so that it's not going to move, and I've got a good connector. Okay, so I'm going to I'm going to rotate that lock ring connector 360 degrees. Like I said, I do it 720. I do it at least two turns, which would be my 720. Excuse me. It changes, that distributes all of the lock ring evenly. Okay. Then I'm gonna make sure that I respect the curing time for the lock prep once I get done. Before I put anything else in, I'm going to let it sit. It's at least 10 minutes. It all depends on the temperature that you're at. Okay, so I'm going to push the joint into the rings into the joint. Okay, this is where I hold it. If you look right there, that's whenever you get it at the beginning. Of course, you're holding it. You start cranking it using. I'm left-handed, so I always put it in my left arm, and I crank with my right hand. I usually crank it and go 1, 2, 3. You'll hear it click, 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 click. Then I release it. Click, 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 click. I release it. It's easier for me doing it that way. Some guys can just hold it and just close it all the way up, and they do fine. I'm a little more cautious. Okay, so you can see in slide number 2, that's on from slide number 1. Okay, I'm pressing the ends together. Once I get done and I pushed it all the way in, this is what happens. It seals my tubing totally. Okay. Like I said, you have to respect your curing time. It has to be at least 10 minutes. But does that mean that I just sit there for 10 minutes? Oh, absolutely not. I'm getting everything cleaned up. I'm getting it ready so I can just take it out I can take my installation kit back out, and I can bring my other kit back in, so that I can charge the system. And as I use that time wisely. Okay, so Lokring support. Okay, there's a dedicated training system in place, in-depth Lokring theory, practice, and then you get certification. So this is the lock box presentation. So here's what it includes: the assembly display kit, hand assembly tool with jaws, lock prep 65, and samples for the Lokring demonstrations. Okay, my available information, of course, is Lokring again. What does it give me? Catalogs, brochures, videos, assembly instructions, and then technical documentation. Okay, this is the conclusion of our program. Like I said, we have nobody in the class, so we're just going to go ahead and complete our class. But one of the things that I always do at the end of the class is that we go ahead and there's an exit video that's about a minute and